Git submodules, the solution that nobody ever wanted. Better than SVN externals? Hello, hello, hello. All right, we're back again. We're going to do it this time. Oh, I know I said that last time, and the time before, and the time before that, and the time before that. But we're going to do it this time. We've got an STM32F746 Discovery board, and we're going to make it say hello world. And by we, I mean me and my friends from the AI community. We're going to be using Google's Gemini. We're going to be using Roocode. We're going to be using an embed ops dev container from Dojo 5. And it's going to work. It's going to work. Learned a little bit more about the STM32 Cube development environment. So we're going to try to follow the directions from them. I heard somebody said they said don't fight with it. Just go with it. So we are going to ride the flow and we're going to vibe. We're going to vibe the flow. I'm Ryan Torvik with Tulip Tree Technology, and this is Vibing with the Flow. Let's go. Okay, so we're going to start out with new directory, new project, better prompt. We'll see. We've learned some of the prompts we've done recently have been having the AI keep track of itself and its progress. And so it's like lay out an actual plan for filling out this, for creating this project, and then keep track of the status of your project creation while you're doing it. And then we've seen like it'll pick up where it left off. Sometimes it'll actually add notes at the bottom saying this is the steps that it's taken. So it's actually documenting its process pretty well, but we have to ask it to. So we'll start with a new directory here. Let's see. New folder's name is Jumpin' Motel. Open. All right, here we are. Do /bin/eo init. All right, trial project, default main, creating repo. Cool. Downloading a template. Let's use GitHub. Let's use Ubuntu. Okay, we're going to add the tool chain. No templates found. Let's do add -l. This is the one I want. Interesting. What did I say before? Oh, EABI. Whatever. There you go. Downloading template. Take care of that some other time. Oh, because we haven't built the project yet, so we don't know. Okay, successfully. Then we're going to say reopen in container. All right. Post create command done. Trash that. All right. Let's install our Roocode extension. Installed. All right, hop over. See you later, alligator. It's got Gemini there. Should have all my stuff, right? Can bring it over. Yep, it's got all my stuff there. MCPs. Oh, no MCPs. Let's hope it doesn't need an MCP. We'll see. I always have trouble with that. Installing the MCPs. All right. All right. Here we go. And I'm saying please a lot. So please create an STM32 project for my STM32F746 Discovery board. I'm going to have use a Git submodule for the the Cube board support package from the repository. And there's the link to the repository. You'll need to recursively clone it. Use tag v1.17.3. Please limit the amount of space this will take up by using a depth of 1. I'd like the project to print out hello world on my Discovery board's LCD screen right there. Can you see it? Can you see it? And then create a design document for this project and also keep track of the project creation process based on the project design. Yeah, let's see. And also there's a file to keep track of the project creation process. Yep. All right. So let's go now. All right. So it's kicked us over into architect mode. Design document and progress tracking file for the STM32 project. Main components. Build process using Platformio. I don't want to use Platformio. Okay, I'll let it finish, but then I'll go in before it continues on. I'd like to not use Platformio. Oh, that's right. It's got Platformio on the brain. Clock configuration. Okay, saving the design. .md. Phase 1, project design. Okay. Hello world. Build and test. Documentation and cleanup. Cool. Hopefully there's going to be a review and approve. Cancel here. Okay, so I interrupt it in the middle. I'm like, I don't like this. Yeah. Gotta go back to our, yep, need to be updated to reflect the new approach. Good. Glad I was here to stop you. Didn't mention Platformio, but oh, it's in there, isn't it? I put that in there. Okay, so it is in architect mode. It's reading the two files, and then it's editing. Okay, so let's see what it did here. CMake. Okay. CMake build system. There, use tag, clone with dep1. Oh, awesome. Ensure incursive initialization. So that's what it's going to do next. Build and test. Oh, we're going to do manual. Okay. Flash firmware on the board. It's going to have to do there. Okay, wants to get init. Get submodule, add branch recursive, external. Okay, do it. Uh-oh. Did not like your request. See, and this is going to be a problem too, because we're doing everything as root. Get clone, dash branch. Yep. External. All right, that'll be fine. We can add it later. And this is going to take a while. All right, so I put it in there. Kind of gave me some errors. I am concerned, but that's fine. All right, started the CMake build system for this project. Should be a linker script. Startup file, yep. System configuration, okay. Gonna look for those in that there. There's a lot of startup files. All right, the most generic one suitable for GCC is there. Okay. A lot of linker scripts. Long list. Try to narrow it down a good candidate for generic templates. Okay, it's creating a CMake file there. arm none.eabi.cmake. All right, that seems fine. Bring it over the linker script. Well, that's neat. Don't worry about that. Okay, it's got our paths. Add more HAL drivers as our project. Okay. BSP drivers. All right, so it's created CMake list.text. Linker script. All right, what's next? I suppose you're going to update. What do you want to do? Implement the hello world application logic. Do you want to compile it first? Make sure that it works. Start with a simple one. Go shooter's got to shoot, right? All right. Let's look. It's been successfully created. Next steps, building and finishing. Please update the progress. Okay, it's going into architect mode. X, 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 X. Okay, hasn't done those things, hasn't done those things. Last updated. Interesting. Okay, so it's just got a last updated. Issues and resolutions. All right. So I might have to keep track of that. All right. Next steps. All right, it's going to ask me to do those next steps. I'm not going to do that. All right, we're going to start a new task. All right, so just build it, dude. I'd like you to build it. Build it. Tell me how it goes. We'll see if you've done it correctly. There's pudding to be had. Crow pudding. Okay. Nope. Nope. No. Yeah. And it appears to be missing the actual build contents. I don't even know what files you created. Make dir build. You need to be in the build directory. Oh, okay, so oh, look at that. Okay. T. All right, sure. Looks like that was successful. There you go. You've got errors, buddy. You didn't even get 10% in. Booyah! All right, so what have you done? Let's see. I'm missing that recursively search for it. I found a template. Write the template out into the source directory. Okay, so that means you put, okay. All right, cool. Yep, run again. Oop, we got further. That's good. Undefined references. Ooh, not all the way to 100%? What? I think you didn't add all the source files you need to build. Yep. Include the necessary source files and include directory for the LCD fonts and HAL power extensions. Honey, add the files. Go again. Oh. Oh, didn't remake. Yeah, didn't do the remake. Yes, yes. Okay. Remove the redundant font sources and add the missing HAL and BSP driver source files. Do it. I think you'd want to just glob them all, right? Wouldn't you want to glob them all? All right. Well, I guess we'll find out. Run command. Okay. Build fires have been done. And run command. Poof. Undefined reference. FMC STRAM. Maybe you should include the STRAM stuff too. 38%. HAL FMC driver source file. Okay, run. Cannot find source file. It's actually a lower layer driver. Okay, there you go. Fixing the CMake file. Thank you. That was successful. And now build. That's it. It built. Whoa. Okay. All right. I'm not getting excited. This is me not getting excited. Look at me not getting excited. I'm not excited. I'm not excited. Are you excited? I'm not excited. Yeah, we didn't check off anything. Please update the progress file of what you've successfully completed. You completed like half of phase 5. Like, come on, dude. All right, you need to update the things in phase 5. Like, come on. All right, good. Verify successful build and binary generation. We've done that. All right. All right, so here we are on our warp. We're going to hop over to, what was the name of the thing? SC Jumping Motel. Okay, build. All right, there's a hex, there's a bin. App hello world.bin. All right, let's see if I can remember st flash. Oh, that's pretty good. So I'm going to want, let's just do the whole bin. App hello world.bin. I like to keep that back. Okay, we got lights on. Okay, the screen is white. Screen is white. Lights on the back. It's plugged in. And go. It's black. Is that black? Yeah, the screen is black now. Yay! Is that right? Let's try putting the elf on there. It happened so fast I didn't see anything blinking. Let's see if we can see the blinking. Okay, and enter. Oh, it didn't make an elf. Yep, okay, so that thing blinked, so it did that, and the screen is black. Uh-oh. All right. Back to code. Okay. All right, so I flashed the firmware and the screen is black without any text on it. Oh, I press the button and it goes white and then black again. Well, that's neat. That's the black button. I press the black button and it goes whoop, white and then back off. Whoop, white. I was not expecting that to happen. What if I touch the screen? Touch the screen? Seems straightforward. All right, it calls error handler, which turns on LED 1. It'd be good to know if this LED is on. 7 is on and LED 2 is on. Okay, so we reviewed the conf primarily for blah, blah, blah. We did not define this. It's not found in the BSP or HAL. This means the starter is hard-coded. Okay. Rechecked. Not a local definition. Ah, found it. Discovery. It's typical starter rest for STM. Summarize the findings. Okay. Main application flow, configuration, potential root causes, and areas to check. I don't know which one is LED 1. Which one is LED 1? I'm not sure which LED is LED 1. Yes! I think it's LED 1's there. As it says LD 1 next to the reset pin. Oh. Approve. Find the diagram showing the physical location of LED 1. Error. Bottom left corner of the board. When holding the board. Oh, yes. Okay. LD1. Yes, so LD1 is right there. Green doesn't help, by the way. I'm colorblind, but I won't deal with that right now. It is off. LD1 is located in the bottom left corner of the board when holding the board with the LCD screen facing the USB connectors on the bottom. Those are down there. So it's supposed to be the bottom left corner of the board. That's LD7. Added BSP LCD display on. You did that? Oh, you probably did that. Let's see. Did you? Did you actually do that? I don't know. Okay, please. This guy tasking me. Jeez. The gall. Okay, so it's been updated with main.c. Please do, yeah, use CMake. You did earlier using, yeah. Okay, that's fine. Let's see what happens. If it goes in the right directory. Okay, it built, I think. No, those are all warnings. All right, so I will go flash it. Okay, let's double check. There's a bin and a hex. All right, so we're gonna watch that little blinky light there. Still nothing. I'm gonna try that again. Just wanna make sure. Yep, these lights flashed. And it doesn't say hello world. Does it say hello world on there? Does it say anything? If I want to do this. Boop, boop, boop. Okay. Womp, womp. Let's see. The screen is still black. I think these warnings are interesting. Read is not implemented and will always fail. Oh, get LED 1 to blink if it passes. All right. All right. Let's do that. I'm interested to see like how you do that. Yeah. Added LED init system and before the LCD initialization. Success path. Okay. The new else block that contains a new infinite loop. So we'll do if and then else, and then I guess you'll have an infinite loop in there. That'll blink. All right. We'll see what happens. Oh, it's supposed to turn on LED 1, but it doesn't. Okay, so it does LCD okay, else blink. Okay, so if it, cool. I thought you already did that. You notice this time it's not really keeping track of what it's doing anymore. That progress.md is like, eh, I already made all those changes. Okay, it's putting mostly comments, PSP LCD init, and then blink. Okay, compile it, do it, cd dot, because I don't want to deal with you not knowing what directory you're in. Okay, back to warp. All right, you go up, flash, no LCD, no LEDs, nothing, nada. Flash page adder 08001234. I'm running the command. All right, so I'm just to make sure I'm running. All right, the LED 1 is off. Bump, bump, bump. So it strongly suggests, and it's not even getting that far, so it's probably not getting past the HAL init. So now it's just, we're literally just gonna do a blink. You got it. Initialize the HAL library and then blink. See if we can get it to work. Task completed. Yeah. Okay. Change the file. That's a lot of crap. It's stuff. It's fine. It's fine. Okay, did that. Go back over to, and it doesn't do nothing. Okay, literally. Oh, wait. I pressed the button and the light came on. I pressed the reset button. Do I have to? Yes. Okay, well, that's fine. So it's a solid, so that's a solid light now. All right. Unless I specifically say dash reset, which I guess I should say dash reset. Please tell me that I haven't been doing this for 2 weeks and all I had to do was press the reset button. It would work. Please don't tell me that. Stuck in a black screen, STM indicating the error. Okay. Error handler is being called from system clock config. My goal is to help you pinpoint which of the 3 critical how calls. Examine the current implementation. Okay. Yeah, so I think it would have been smarter to build this up and just like get it to blink first and then start to go from there. But all right. Okay. Common reasons for failure of each how function. Clear diagnostic strategy. Nope. Yes. Let's do LED toggling to indicate progress through system clock config. We're going to do printf debugging with an LED. Why would you want to flash and not reset? You are certainly taking your time there, buddy. Moving that to initializing it off in the main function. Blink sequences at 3 different points with the system clock config function. Oh, interesting. Am I going to notice that? So that's going to blink once, and then 1, 2, 1, 2. Is the delay going to be long enough? And then 1, 2, 3. Oh, interesting. Okay, so I got to pay close attention. Got to pay close attention. All right, so when we flash it, so, 1, 1, 2, 1, 2, 3. If at any time it doesn't blink that number of times, then we'll see. Oh, what are you doing now? Don't change anything now. You already did it. That's really confusing. Why are you editing the file again? Okay, rebuild. Got a CD again because CMake. Okay, built my main. All right, back over to warp. Okay. Okay, it's hold on. Did it flash? Okay. I'm going to the reset button. One. Nope. The light is still on. It doesn't blink at all. Where's the first place? I mean, you tell me. Is that blinking? Is that thing blinking? I mean, maybe. It doesn't blink at all. I don't. What is going on? What does this do? I mean, honestly, almost immediately, but all right, we're gonna cut bait and run in a minute. You haven't been keeping track of your progress. All right, so you made some kind of changes. Let's see. What did you do? It's indicating the failure is there with the RCC OSC config, but it doesn't blink. Like, I didn't see a blink. So it modified to primarily use something else. The diagnostic should be in there. Final slow blink leader should also remain solely for making specific clock configuration modifications for diagnostic purposes. So it did all that. I just built it now, and we're gonna go back over to warp. And we're gonna build, we're gonna push it out. Okay. Okay, so it did like this, and I pressed this button. No, I got nothing. Done for the day. I mean, at least the screen is white now. So that's nice. All right. That's enough. That's enough. That's enough. Okay, well, that was fun. Well, the board support package is at least in the right place. The compilation worked pretty smoothly. The CMake file is pretty clean. But still nothing on the screen. Nothing on the screen. Not even blinking lights. I wonder. But I don't know. So we'll try again. Glutton for punishment, I suppose. So hopping down there, smash the likes and subscribe buttons. And we'll see you again next time.